Continuing in section 10.5 with multiple regression, here we're actually going to look at a problem where we had to enter data in and try to calculate out what the best equation is. So I'm going to be looking at number 14. On number 14, it basically tells us to repeat the previous exercise. So it says, given that we are using, number 13, we are going to be looking at 100 millimeter filtered non-menthol cigarettes. Let's go cigs here. So as we're looking at these cigarettes, they give us this table of information where now we start comparing nicotine, tar, and carbon monoxide. So what we're looking at here is we're trying to figure out what is the best indicator for nicotine. Okay, so our y hat value is our nicotine. I'm just going to go nic. And then we have x1 is tar, x2 is carbon monoxide. And what we're going to do now is we're basically going to try to figure out and calculate out what the best regression is going to be for this and basically show that we have this. So one of the things to remember on this is we have multiple things happening. We have this overall list of equations that give us a possibility. Okay, so this is basically taking a look at tar and carbon monoxide influencing our nicotine as we're doing this. So as we write our table here, we're going to look at influence, okay, equation, adjusted R squared, okay. So as we consider what's happening here, we're going to write this out very informally until we get to our final answer. Then we'll formally define what we have going on. So we can start off by writing the single ones, or we can start both and work our way down, whichever way we want to do it. I'm just going to go like this and go tar, carbon dioxide, and then we have tar and carbon monoxide. Okay. So as I write my table here, notice this equation is going to be y equals, I'm going to have a b naught plus b1 x1. This is going to be y equals my b naught, and now I'm going to label this one b1 x2 because I'm pulling it from my other one here, and then y equals b naught plus b1 x1 plus b2 x2. So let's just take a look at both of these influencing one another. So now we're going to have to go to our table. Okay, so one of the things to reference in here is the fact that we have this table that's given to us. Okay, so what I did was, and you can kind of see this if I hold it up maybe a little, you can see I have my tar, nicotine, and carbon monoxide from my table in the back. So in the back of the book they had brands of cigarettes, and then they listed out all this information that's on here. What we're going to do here now is we've got to find our adjusted R squared values for each of these. In order to find those adjusted R squared values, there are two ways. We can stay in this, but do realize if we stay in this, we run into some problems. So I'm going to suggest that we bring over to a calculator, bring a calculator into our tabs, and then what we'll do is we'll go menu, statistics, stat tests, and then we'll do a multiple regression test. So it is under B choice right here, that multiple regression test. Okay, so once we get this multiple regression test, it's going to ask us the number of independent variables. Okay, so in this case we're starting off with just one, just the tar. So what I'm going to do is y was my nicotine. And then I had tar, arrow down here, tar was my first, nicotine, sorry, forgot to arrow down to my X. Now I'll go down to my tar, and we see that right here, let me get that to where you can see it. Right here we see that we have r squared and then our adjusted r squared value. Okay, so that adjusted r squared value is what we're looking for in here. So the adjusted r squared value for this one is 0.8767, so 0.877. And then what we'll do is we will then repeat this. We'll go menu, statistics, stat tests. Looking at that multiple regression, we'll do a single one again, so we'll have one variable. Once again, y is our nicotine. And then now we're going to reference for carbon monoxide. On this one now, we see that our adjusted r squared value is 0.4369. So we go 0.437. And then what we're going to do now is we're going to do it for both of them. So menu, statistics, stat tests, multiple regression. Only now we're going to have 2. Okay, so now I'm going to enter in 2 into here. Here you go. 2. We're going to enter 2 independent variables into here because now we're going to take both consideration. So notice our list changed a little bit here. I want tar was my first one, so I want to keep it that way. And then CO was the second one then. So notice I just want to try to keep that X1, X2 to follow what I defined in there. So we can see that we have nicotine, tar, CO. Once again, Y was nicotine, X1 was tar, X2 was carbon monoxide. So we want to kind of keep it that way. When we hit enter here, we notice that now our adjusted r squared value is 0.927. Okay, so once we're at this point, now we look back and we say, okay, what has given us the highest adjusted r squared value? Once in, take consideration that the more things we have of our complicated equation is, but if it is a better equation, we should be considering that. So if we look here, we really need to consider the fact that, hey, both of these is giving us such a better one. Once again, we're getting a 0.927 versus that 0.877. So I mean, that's an overall 5% more accuracy in there, which is a significant value in itself. I mean, so we really want to choose this one. So we would have our indicator here. Now what we'd want to do is we'd want to write the equation for this. Now, part of the problem with the calculator function here is it's not really easily to find what our list is in here and choose our values. So that's where I would suggest going back to your stat sheet. Okay, once we're back in our stat sheet, we can actually run these tests like we did before, only it's going to line things out a little bit better for our problem. So what we're going to do is we're just going to rerun the one test. So in here we're going to go menu, statistics, stat tests, and then we're going to go to our multiple regression test. We have 2 variables that we chose. So this was our nicotine. Our X1 was tar. Our X2 was carbon monoxide. Okay, and in here, notice we still get that same adjusted r squared value. Move this down a little bit so it's just a little better. So we still see that we're getting our adjusted r squared value. It's this one right here, 0.927. So 0.927 was what we had here. But one of the main features on here is the simple fact that if we notice, it lists out our formula. Okay, so under that regression equation, lists out that formula, b0 plus b1 times x1 plus b2 times x2. So if we come down, I'll go down just a little bit, we will see our b list. Okay, On that B list, it gives us B1 or B0, B1, B2 kind of lined out on here. So interpreting on that list now, we could come and say that our Y, or our nicotine, is going to equal 0.127, because that was our B0, plus 0.0878 x1 plus, actually it's a negative, it's going to go negative 0.0250 and then x2. So I'm just going to clean this up because I messed up on that and the writing here. And we see that this is our indication. So now we have our two inputs that lead to our output. So if we wanted to predict anything on here, we would be able to take this and decide and find what the tar is in a cigarette, what the carbon monoxide value is in a cigarette, and then we'd be able to best predict the nicotine that would be in that cigarette, given this equation right here. Now granted, this is only a specific type. This is our 100s filtered non-menthol cigarettes. So there are many different types of cigarettes that can go into play with this. So do realize that this would be the best way to do it. So let's see, it's best value R squared. We could also go back in here. One of the things, let's see if I cancel. If I go back over here to my list, once again you could see that there's a p-value. Notice the p-value for my last one was 0.127 times 10 to the negative 13th. Okay, if I come back up here, my p-value for this one was 0.000193. My p-value here was 3.7 times 10 to the negative 12th. Okay, so it's making sense that these are both close, but because those p-values are all extremely small, I would say that the adjusted R squared is really what we want to look for. That is the best indicator for this.